Thank you very much. Actually, I'd actually like to. I have a point of contention in the theme of this track, which is this idea of smart objects. I actually disagree that you can make smart objects. I don't think that objects can be smart, but I think we can make them help us act smartly. And this is going to be the theme of my talk today, that actually the smartness does not reside within the phone. It does not reside within the matter. It resides within the behaviors or activities that it gives rise to. That's where the smartness or intelligence lies. I'd also say that we don't actually want things to be smart. You know, sometimes a really, really smart person is really not a very good friend. You know, you don't necessarily like really, really smart people. I mean, they're very good at certain things, but you really don't want to hang out with them all day. So I would actually say that we don't really necessarily want things to be super smart. Also, this idea that smartness somehow lies in instructing us, I would also take issue with, because just to take an example from the presentation that referred to, for example, an app that can tell us how to exercise when we're exercising incorrectly. The fact of the matter is that even human exercise instructors tell us different things. They have different opinions. They instruct us in different ways. They have different methodologies. And if you were to develop an app that was to help us act smartly, it would necessarily have to be an open app where anyone could start to build in that exercise consultation service. And that's the really crucial thing to enabling these kind of smart behaviors or activities. It's that openness. It's the capacity for people who are smart to take these dumb objects and to help each other. It's the idea of building up connections between people that I think is the really important thing that enables us together to come to intelligent decisions. And that's much of the reason why I launched Patchbay, which is essentially it's a kind of data infrastructure to enable devices to communicate in real time with each other. And it's a web app, it's an infrastructure, it's also a community. And people are using this system to connect up weather stations, energy monitors, air quality monitors, biosensors, building management systems, all sorts of things. If I go to the website for a second, just to give you an example of the kind of data that's going through here, this is our fire hose, and you can kind of see in real time all this data is going through this system, and it's coming from a wide variety of device. If I go to CloudView, you can see just looking at the tags of this data, there's just a huge amount of different stuff that different people have created. They've founded new ways to build applications and services on top of our API. And it ranges from things like temperature, energy, there's the carbon footprint app, there's the alert app, there's the, you know, it's all of this stuff that has enabled creativity in people that I would argue has given rise to any notion of smartness. To get to a really concrete example, in Japan recently, with the nuclear situation, radiation tracking became very important, tracking radiation data. There had actually been a Geiger counter on Patchbay almost from day one, just by chance, in a lab in Japan that was just measuring radiation. And people started watching this Geiger counter that was on Patchbay because basically you can see all the graphs in real time, what's happening. And pretty soon, through tutorials that other people created to show each other how to wire up their Geiger counters, how to take radiation measurements, the Patchbay community created basically a countrywide real-time sensor network that was tracking radiation data, that was giving rise, really importantly, I would say, to conversations around what are these measurements? What is important about microsieverts versus nanogray, that actually helped people to make sense of the radiation data. So it's not just about taking the measurement, building up this kind of crowdsourced repository of data. It's that capacity to give rise to people's desires for knowledge, desires to communicate with each other's other desires to understand what this data is. And as a result of having this kind of central repository that was tracking actually many different types of sensor data stream from different models, different value, different units, the community started to standardize on how best to represent radiation data. And they started to build these applications for visualizing that data or for making sense of it. So here's one by a London designer called Haque, which is essentially a map that is plotting the values. Then an Android app came out called Winds of Fukushima, which took the wind direction, compared it to the radiation values, and essentially gave you an idea of where the radiation was going to peak next. There's another one here, which is basically just visualizing in 3D what the real-time radiation data is on the system. And so on and so on. A whole bunch of more applications came out. Different organizations started building stuff around Patchbay's radiation data. There's now these sort of the Geiger Counter configuration tool that people use. There's also the SMS alert app, so you could put an SMS alert on your nearest Geiger counter. You now don't need to have your own Geiger counter, because chances are somebody is measuring radiation near you. What's interesting is this is now spread on Patchbay to other countries. People have created some radiation, or have put radiation data in from Spain and from Germany and from Switzerland, and increasingly now in the US as well. So there's a bunch of apps now that have been built on top of this Patchbay data. There's stuff for monitoring, there's stuff for triggering things, for controlling things. There's Radar, which is it's a Nokia app where you can basically go and stand on a street corner and search for your nearest whatever, weather station, your nearest air quality monitor, your nearest energy feed. Or there's things like Porthole, which is a sort of augmented reality app where you can take this real-time data and overlay it on sensors. And it essentially, what you see here is a color code for the kinds of sensors that are plugged into that device. Brown is carbon dioxide in the environment. Yellow is light level. If you press a button, then you can see which one has varied the most over the last 24 hours. So brown, carbon dioxide has not varied so much, but light level, further from the center, has varied quite a lot. Press another button, and you can see the current value in the context of its historical max and min. So carbon dioxide is roughly in the middle, light level is quite high. Another button gives you the graph of the last 24 hours worth of data, and you can now drill down through it. So this is the kind of thing that becomes a lot easier to build once you have the data infrastructure for taking care of these millions or billions of data points. Another way that people have used mobile devices with Patchbay is in this idea of context. And this is actually something that we did to illustrate the importance of context. The typical example that you often give for these sort of networked infrastructures is switching on a coffee machine from afar, switching on a coffee machine remotely. And so we did the Patchbay version, where we took a coffee machine and we plugged it into a Siemens logo controller. Now, instead of saying, okay, let's take data logger and let's trigger the coffee machine to switch on, we said, instead, let's take all of the context for each of those people, the context for the coffee machine itself, and develop a system that enables people to be much smarter about how much coffee they're drinking or how much energy they're using. So what happens is that you use data logger, you say essentially, I want coffee a lot, or I only want coffee a little bit, or I would have coffee if it was already made. Because as you may know, often in organizations, or at least in small organizations where you don't have a fancy coffee machine, you lose a lot of energy by switching on the coffee machine, going back to your desk, and then forgetting that you had it boiling there. And so we're trying to figure out a more efficient way of using this. So what happens is that the system aggregates the relative desire for coffee with the distance from the coffee machine and compares it to how much energy has been used over the last 24 hours, and on that basis decides whether or not to create the coffee. So if there's a lot of people who really, really want coffee, the coffee machine will go on. If there's a bunch of people who are not really that keen on it, then it won't bother to switch on. Finally, last week there was this announcement for about Androids has now got an Arduino. Arduino is this open source microcontroller which a lot of designers and architects and developers are using around the world to build sensor devices, to prototype sensor devices, and also to create products. Google has announced that there's now an Android-branded Arduino. This is just going to open up a huge amount of creativity and, to my mind, actually result in a lot more smart use of mobile phones. Thank you very much.
Usman, thanks a lot.
Thank you very much.
I think that was mind-blowing. Can you just please stay up for one question? I was wondering, do you suggest that it's smarter to pursue a grassroots approach to data, or what the other speakers proposed, like opening up the available data of big corporations and public institutions?
I think it's a little bit of both, because there's certainly a place for official data sets. But very often official data sets, which are also clean data sets, have been looking at a very particular type of data. Very often they might have stripped off stray data points or outliers, as they say. Now, what the sort of crowdsourced or grassroots idea of open data brings to this is the capacity to look for stuff that maybe nobody else was looking for, and discovering interesting other things. And I'll just give one example of that: air quality monitoring. The official air quality monitor pollution sensors are usually placed, 2-3 meters above the road, and they create a lovely map of what the air quality distribution across the city is like. But if you took that same air quality monitor and measured it at the height of a stroller where children are, you'd find sometimes 1,000 times as much pollution. Now, you get lots and lots of local maxima, and you don't really get the aggregated sense across the city. But what you do get is the information that a parent who's got that child would be much more concerned about. And so that's why I think there's a place for both.
Thanks a lot.
Thanks very much.